So that gets, yeah, so that gets you down to x plus 8 squared. You divide by 2, very good. And then the number that goes in the red box, it comes from that number there. Do you remember what you do with the 8?
We get square the 8.
Square the 8. So that becomes plus 64 plus 64. All right, so that's really helpful here. On the right side, it becomes 0. Normally it's not 0. Normally it's a number that you then have to bring back over. But this is now on the left in vertex form. So let's just say it was like 10 on the right, you would subtract it over. But this is now in vertex form. So y equals x plus 8 squared. Any questions on that?
No.
Okay, so the next, we'll do some more. I mean, this it's a little bit similar to what we've already done. The next one will be a little bit clearer because there actually is a number to look at. All right, here we go. All right, so again, my preference here is to like write this equal to 0, move the number over. So this becomes x squared plus 8x equals -3, like that. And then you have to fill in that space in the middle. So can you help me out here? Tell me what might go in that position or what goes down here?
X plus 4.
X plus 4, good. If it were -8x, it would be -4 down here. When you square it though, it's always positive. So 16 goes up in this box. So notice the right-hand side is not 0 this time, it's 13. And so this is the difference between solving by completing the square and writing it in vertex form. Here, you're just going to move the 13 over. So you're going to subtract 13 from both sides. X plus 4 squared minus 13. And that's your answer. Now, normally you have to determine the vertex, but this one just wants it in vertex form. We can come back to that if there's time today. Like usually they want you to write the vertex after this, but all right. All right, why don't you try number 3 on your own? Let me know if you have questions along the way.
All right.
How are you doing on this one?
Pretty good.
Did you add 25 to both sides?
Yeah.
Okay.
I got x minus 5 squared minus 10.
Yes. Because it equals 10, so you subtract 10 from both sides. And you get y equals x minus 5 squared minus 10. Good. Now there's actually, I mean, more complicated examples than that. I apologize if that wasn't the first one you wanted us to do. Oh, it is 8.2a. Okay. Are there any other problems on 8.2a worksheet? Or is it just moving?
No.
Okay. All right, so we'll move to 8.2b. All right, so here's what we're going to do here. I'm going to just snip these in, but I'm going to switch over to Desmos so we can sort of learn the rules. So we're going to kind of look at the first one, and then we'll come back and look at the second one and so on. So let me new share the Desmos calculator. So it says to start with y equals x squared. That's the U-shaped graph. You've probably seen that many times before. So let's talk about some transformations. All right, so I'm gonna unhide that. Let me do this differently. Okay. Do you think this moves right or left? X minus 5. Or do you, and if you don't want to guess, that's okay too.
I think it would go left.
Yeah, so that's the most common answer, but it actually moves right. And that seems very backwards, doesn't it?
Yeah.
So that's one of sort of the wrinkles, warts of this part of the course, is explaining like, why does this move right? And the answer, it depends on like how much, how much information you want. But it does move it right when it's minus inside here. So what most students remember is that it's the opposite of what they think it should be, or they remember if it's a negative, it goes right. So if it's plus 5, you can see it goes left. Does that, I mean, do you see that? Do you agree with that?
Yeah.
All right. So if I make this a C and add a little slider here, you can see that, it moves left when it's positive values, right for negatives, and so on. It's kind of an animation, I guess, in some ways. I don't know. Would you call this an animation? What this does here?
Yeah, I guess in the way it functions.
Yeah, maybe not a pure animation, but so the key here is to recognize that inside parentheses, if it's like plus, plus 5, it moves left. If it's minus 5, it moves right. Somehow you have to believe that. Okay. Is that all right?
Yeah.
Okay. Now, the next type of transformation is more intuitive. Okay. Let's say I write plus 9. Do you think this goes up or down?
I think it would go up.
Yeah, this one's more intuitive. So it does move up. Minus moves down. Okay, so there's some rules here. I'll try to summarize those on the other screen here for you. So the left or right transformations, that's inside parentheses. So if it's x minus c, it's right c, and if it's x plus c, it's left c. Is that okay? Is that clear?
Yeah.
Kind of like the quadratic formula, just got to find a way to remember that. It does apply to other things that you'll see in math. So like later on, someday you'll look at trigonometric functions and they actually follow the same rule.
Okay.
All right, so then up, down, and these are squared, sorry. X squared plus C means up C, X squared minus C means down C. So let's take a look at 1A, again, just the equation. I'll snip that in here and let's see if we can answer it. We've already sort of done it graphically, but let's see if we can answer it by just looking at it. So you always start kind of inside parentheses. So -5 is 5 to the right. And the 9 would be 9 down. Is that clear?
Yeah.
Okay. Now, not to try to over confuse or over complicate this, but the order does matter. Okay. And sometimes you might, think, well, why does order matter? Let's say your house is here and you want to go to a friend's house here and you can go north and then east, you still get to the friend's house. Okay. And the order matters, right? Like you have to go this way and then this way. But you could also say, well, can't I just go east and then up north? Sure, that works. So, but in math functions, sometimes the order actually really does matter. So you really do want to start inside the function and work your way out. So like if you tell me 9 down and then 5 right, I'm going to say, well, let's do it in the right order here. 5 right and then down. Okay, let's look at letter B. Letter B here. All right, so what does this x plus 2 inside parentheses do?
That would be left. 2 left.
So you could say 2 left or left 2. Sometimes they want you to actually write the word shift. Depends on the teacher. How about this -7? What does it do?
That'd be down 7.
Yeah, 7 down 7, whatever you like on that. So notice I've left a gap here. That's because there's this 5 on the outside. So let's go back to the graphing tool, which is now okay. Let's look at this now together. So now this time, we're going to put a value in front of x squared. We'll call it 5. Okay. So let's take a look at this. So this is considered a vertical stretch. Okay. And if you want to know why it's a vertical stretch, it's because the point 1, 1, you see that on red there, it's vertically stretched up to 1, 5. It's like pulling something up.
Oh.
Okay, which you could almost argue here, well, isn't it kind of stretched in? It's technically considered a vertical stretch because of where it is on the function. It's outside the function. All right, now let's say I change this number out in front to, let me change these points, get rid of these points for a moment. Let's say I change it to 1/5. This is considered a vertical stretch, compress. Okay, so that same point 1, 1 is now at 1 over 20, 1 over 5. I don't even know if I can see that on here. I think you can see it. Yeah. So this point went down that way. So let me go back and summarize here. So if you have a number on the outside, so if you have y, k, x squared, if k is greater than 1, it's a vertical stretch. If k is between 0 and 1, it's considered a vertical shrink or compress. You might check with your teacher to see what they like. The keyword vertical is very important, very, very important. So you have to say this one is a vertical stretch of 5. Is that okay so far?
Yeah.
Kind of, okay. All right, so let's do number C, 1C. We will have to go back to the calculator for this one as well. All right, so C minus x minus 6 squared. Inside parentheses there, what does that, what happens with that? What does that x minus 6 do?
That's right.
Right, 6, yeah. And maybe you saw this in class. Do you remember at all what that negative does?
It just makes it go is that upside down or
Yeah, yeah.
on the graph?
So let me give you the preferred wording, we'll say. So I put a negative in front of x squared. It's called a reflection over the x-axis. Reflection over the x-axis. So that's what they expect. They expect that that type of wording there. So reflection over the x-axis. If you just say reflection, you might be okay now, but later on or in another course, that will not be okay. All right, any questions on that before we move to another problem here?
No.
We should do some more of these if we have time. These are like where I just basically give you the graph, or I'm sorry, the equation, and say, give me the transformations, but we don't, we'll just get through everything else before we do that. All right, so let me grab the next question here. Just make sure this aligns with your question too, because I couldn't really tell from the way these came in. Is this the next one to work on?
Yeah.
Okay. So what I'm going to do here is write the standard form of a quadratic underneath. A x minus h squared plus k. And the vertex is actually the first thing we want. The vertex is h comma k. So if it's a negative inside parentheses, your h value is that number without the sign. So you see how the minuses line up? So h is just that number. H in this problem is just 2.
Oh, okay.
K is whatever's on the outside of the parentheses. Whatever's outside. So what is the value of k?
3.
3. Good. Okay. Now this is that point where it either goes up or it goes down from. All right. Oops. Okay, now the axis of symmetry is always x equals h. So whatever the h value is from the vertex, that's your axis of symmetry. So that's x equals 2. Is that okay? Clear?
Yeah.
All right, now I want to quickly go back and graph this. I hope going back and forth with the graphing is okay and not too distracting. Because I want you to see like what do these things actually mean here. So let me graph the original one here. So oops, x minus 2 squared plus 3. Hit the home button. So see how the vertex is at 2, 3.
Yeah.
That's what we expected. Now let me write the equation of the axis of symmetry. The axis of symmetry equation has to be an equation is x equals 2. Do you see that this line right here, it equally divides the right half from the left half and it goes through the vertex?
Yeah.
So it's kind of like a mirror. It's like the dividing line, like you're on one side or you're on the other. Any questions on that before we go to the graphing of this?
No.
Okay. All right, so the rest of the problem says to graph this, right? It says to make a graph from the table. Now, I normally show the table differently than this. I think you'll prefer the way I would show it here, but we do have to fill in these values probably. So I go right to the vertex, and that's my center point on the graph. Okay, and then I choose two values smaller, which is like 1 and 2, and then two values larger, 3 and 4. Now your table doesn't do that. So this up here is considered like the standard set, but you'll see that this really won't work for this problem. Okay. And we'll maybe talk about why here in a moment. So to get the y values, you have to put each of these x values into this one here, into this equation. So I'm going to do it down below here where I've got a little more room. So I'm going to start with x equals 2. And I'm putting that into the equation y equals 2 minus 2 squared plus 3. Order of operations, you subtract inside parentheses first, then you square, then you add 3. So this ends up being just 3. Is that okay?
Yeah.
Okay, so that would go back in our, oh, why did I'm sorry. We already have that value. Boy, that was silly. I apologize. This is really, really silly. So we don't want to do that. We already have it. We want to do it at 0. X equals 0. That's really bad. Okay. So we're going to put 0 in for x. 0 minus 2 squared plus 3. So 0 minus 2 is negative 2. Negative 2 squared is 4. 4 plus 3 is 7. Okay. Now I want you to put in this value of x equals 4 into the equation. So it's going to be y equals 4 minus 2 squared plus 3. And I want you to simplify that.
It'd be 7.
Yeah. Now you should not be surprised by that. Like maybe you are the first time you do it, but there's this symmetry that you'll see on the graph we're going to look at next for those 2 points. And it also applies to the 1 and the 3 because they're 1 away from the vertex. So we're going to do the same thing here for 1, x equals 1, and that's y equals 1 minus 2 squared plus 3. That ends up being 4. So 1 minus 2 is negative 1, negative 1 squared is 1, plus 3 is 4. And I'd like you to do the other one here. X equals 3. So that's 3 minus 2 squared plus 3.
It'd be 4.
Before again, yeah. Now, this is always the case. This is always the case that there's this symmetry to take advantage of, but you have to put the vertex in the middle of your table. All right, so you're going to want to graph these points, and I'm going to do that in the other screen here. But once you get the vertex, when you choose 2x values larger and 2x values smaller, you don't have to compute them all, because by symmetry, the one that's 1 away is the same as that's 1 away on the left. Same, that one that's 2 away on the right is the same as 2 away on the left there. A lot of times it's like, oh, there's so much work to do, but really it's not. So you on your graph want to put dots at each of these ordered pairs. And I will do the same here in that other window. All right, so let's assume I don't have that graph for the moment, and I just want to start plotting the point 0, 7. And you can label there in Desmos. Are you using this tool at all in school?
Yeah, a lot.
Okay. I like hearing that. You can even label the points here. You can say like, use letter A if you prefer. I would always just use the ordered pair. That's better. You'll do that in geometry. Uh-oh.
Oh no, my dog.
Everything okay?
Please shut up. Come on. Go bother someone else. Go over there. Sorry about.
Yeah, no big deal. Dog doesn't bother me. Are you okay to keep going though? I don't want to.
Yeah, I'm good.
Okay. You can mute yourself if you need to. If you want to, it doesn't really matter. But what I want you to see here is that there is this symmetry here. So let me go back and graph it, and you should see all the points go in there. And if you remember, there's that x equals 2. You should see that there's that point left of it and right of it, left of it and right of it. There's always this symmetry to take advantage of. So when you're graphing it, they expect 5 points, but really you just need the vertex and then 2 other points on one side, because by symmetry you get the other ones. All right, so I should snip that in. Let me do that. All right, now we'll go back and look at your next problem here. Okay, let me go to the other screen. All right, there it is. Let's see what else you've got today. So that takes care of number 2. Number 3 is really similar. Oh, and then 4. Okay, I got it here. All right, let me snip in number 3. All right, so what I'd like you to try to do is give me the vertex, please. And if you don't want to unmute, if you could drop it in the chat, or you could unmute real quick. Either way is fine. It's really important, though, that you be able to find the vertex. What do you say here? What's the vertex? Give me the x coordinate comes from in here.
K is 8.
Okay, 50%. So that one's exactly it. The other one is the opposite of maybe what you would think it would be.
It's
-1.
-1.
Yeah.
Oh yeah, because
Yeah. So the axis of symmetry is an equation. It's x equals, it's the x value of the vertex, which is -1. So now the tables that I prefer here, x, y, you put that vertex right in the middle. And then you need two values larger, like 0 and 1, and two values smaller, -2, -3. All right, so now that you've got those, you can fill in the y by putting these values into the equation. So you don't have to do them all, you just have to do the nice ones. And I would choose like the positives or 0. That's always better. So you would try x equals 0, y equals -2, 0 plus 1 squared plus 8. This is where you got to remember your order of operations. So order of operations says inside parentheses first. So 1 squared exponent. So that's 1 times -2, which is -2 plus 8. And it's okay to write out these steps. And so -2 plus 8 is 6. So by symmetry, this is also 6. So you really want to make sure you've done this correctly because you get, double the value here of doing 1. All right, so why don't you try x equals 1 for me? And if you need to, you can just unmute or drop it in the chat when you get your answer there.
You got 0?
Could be.
Could be.
Yeah, I think that is right. That does look right to me. And then that one again by symmetry. All right, now because of this negative out in front, you know that the graph opens down. So when you go to graph these points, I actually prefer you start in the vertex. I know I graphed them just down the list on Desmos, but I would, by hand, I would do it on the, start with this one and make sure that these other points like line up. So if you don't mind, give that a try, and then I'll snip in the graph and you can just compare with that, please. Are you seeing those line up as you graph it?
Yeah. Oh no, what did I do? I accidentally refreshed the page.
What does that do? Does it give you a new problem set? Or are you graphing it in
I was
Desmos?
graphing it and I
Okay. Yeah, I don't think it saves anything unless you got an account, which I've never bothered to sign up. I probably should. I use this. I mean, I've probably used this for 10 years and it's really great, but okay, let's if you don't mind, we just jump to the last and make sure we get it all done. I mean, you can go back and get this from the notes if you want. Like you to tell me the vertex of this one, please, and look back at the previous one to make sure you've got it. What do you say here for number 4? What's the vertex?
I got 2 and -6.
So it's actually -2 and +6 or a -6. So that K, always perfect mapping, that one inside there is going to be the opposite sign. So maybe we should make a note of that. Opposite sign. Axis of symmetry is always the X value of the vertex. And then we've got to make that table here, X, Y. So you're going to start at -2, -6, 2 larger, 2 smaller. Now let me do a little shortcut here for you to save you some time on these. Let me go to the Desmos here for this. And let's see here. Let me graph here. Y equals 2x squared. Sorry, 2x plus 2 squared minus 6. So a lot of students, they'll try to trace this, which you can do, but it's not really the best thing to do here. Just labeling the vertex here. They'll try to be like, okay, let me just get it. And that works, but it's kind of slow. So here's what you can do. You can do like x equals -1 and find the intersection of it right there. So that gives you that other value in the table. And then if I change this to -3, it gives me the value in the table. And then if I put x equals 0, if I can find my mouse cursor, there it is. You can see that where it intersects there, it's at 2. So that will save you a little bit of time if you don't want to evaluate it each time. Obviously, this is because you've got this in front of you. So you can see all that symmetry there when you're graphing something like this. So let me go ahead and snip this in to the screen. I hope this helped. I really don't know what it's like to be a student right now you got all this technology and then you go into this classroom, they're like, no, do it by hand. You're like, why?
Yeah, it kind of sucks.
Yeah. So might be, in kind of a nice way, maybe ask you, hey, I know we've got to do this by hand because we're students here, but like, is there something else I should be looking for? Is there another way we can use this tool? I mean, there's got to be better options than just doing it by hand here. So I was filling in the table from those points. Again, the key thing is getting that vertex in the right spot there. All right, any final thoughts? I think we got through everything today.
Not really.
Okay.